Hey guys, and welcome to the school station. Today's video is going to be about specific heat capacity, and this is the practical version. In my previous video, I talked about specific heat capacity, and I said that there is a required lab practical for specific heat capacity for AQA GCSE physics. So today I'm actually going to be talking to you guys about the practical and the instructions for it. This is from the AQA GCSE physics 91 paper from the unit Energy and Energy Resources. So I really hope you guys enjoy this video, and I hope this helps you for your practical, and let's just get right into the video. So first of all, we are actually going to be talking about the setup itself. So this is just a normal setup of how this experiment or practical should look like. So over here, I just have a block. So this is an aluminium block over here, but you actually have to choose a material. For example, it can be a copper block or an aluminium block. You also have a thermometer because obviously we're calculating specific heat capacity. So we will need a thermometer for that. And we also need a heater. This is 50 watts, but obviously it can be usually any temperature that you want. And then we basically have to set up the practical according to a parallel circuit, because we need to actually connect a voltmeter and an ammeter. The voltmeter is actually to calculate the potential difference of the voltage, and the ammeter is to actually calculate the current. So that's basically how you would actually set up the practical. And now I'm actually going to talk to you guys more about the method of this experiment. So number one, you actually have to choose a material, for example a copper or aluminium block, and measure its mass in kilograms. Number two is to wrap insulation around your block or beaker. Number three is to smear petroleum jelly around the bulb end of the thermometer, but this is not necessary if you're measuring the temperature of water rather than of the metal block. Then put the thermometer in a small hole in the block or into the water. So as you guys can see over here, the thermometer is in the small hole. Number four is to measure the starting temperature of the block or water. So obviously it depends on what you are calculating the specific heat capacity of. So you want to measure the starting temperature. So when you just put the thermometer inside, what does the temperature say? Number five, put a heater in the larger hole in the block. Connect the ammeter, power pack, and heater in series. Number six, connect the voltmeter across the power pack. Number seven, turn the power pack to 12 volts, or according to what the voltage your teacher says, and switch it on. Start the stopwatch as you turn on the power pack. Number eight, record the ammeter and voltmeter readings every 60 seconds. These may vary slightly during the experiment, but not significantly. Record the temperature of the metal block of water every 60 seconds. If you're using water, stir it at regular intervals. Number nine, after 10 minutes, turn off the power pack. Number 10, keep the thermometer in the metal block or water for a while longer. Record the maximum temperature of the metal block or water in table 2, which I'm actually going to be showing you guys more later on. This may be a little while after you've turned off the power pack. So now that we basically have finished the practical, you actually have to record your results while you are doing the practical. And I'm actually going to show you guys a representation of how your table should be if you're recording your results. So this should be table 1, and this is actually to calculate the power of your results. So we basically, as I said in the experiment, you basically have to record your results every 60 seconds, and you also need to actually calculate the potential difference and current every 60 seconds. So you basically need a timer, and every single time it reaches 60 seconds, you basically have to quickly calculate the potential difference, the current, and then you also have to calculate the temperature of the metal block, which is going to be on table 2. So when you're doing every 60 seconds, you basically fill in this potential difference, the current, and then in table 2 you also have to do the temperature of the metal block. So obviously in 0 seconds, this is going to be the initial temperature of how the temperature actually is when you first start the experiment. And then after you've actually finished your experiment, what you basically have to do is you have to actually first of all calculate power in this table. So the way you calculate power is you actually do voltage times current, or potential difference times current, and you basically just multiply these two together, and you basically calculate the power, and you do this as you go down the table. And then when you actually go onto table 2, you basically have to take the power, so you just do 0 seconds, the power that you get for 0 seconds, you basically have to multiply that with the time. So for example, in 0 seconds, let's say the power is 20.0385 watts, and then you times 0, which is obviously going to be 0, and then you go back to this table and you have 60 seconds. In 60 seconds, let's say it's 20.4045 watts, and you multiply this with 60 seconds and you should get your energy transferred. And again, you go down along the table. So that's basically how you're going to be recording your results. And then the reason why you're actually multiplying power and time is because the formula power is equals to power times time, and this is basically how you've done it. So after you basically use those two formulas to actually fulfill or just complete your results tables, after that you actually have to usually draw a graph for what you have actually found out. So you would usually have a graph paper, and you would actually have to put on the y-axis the temperature change, which is obviously from this section over here, and the energy transferred, which is in joules, on the x-axis. So the energy transferred is obviously the independent variable in this experiment, and the temperature change on the y-axis is actually the dependent variable because it is what you're measuring. So that's basically everything that we have for how to actually finish the experiment and do it on graph paper. And obviously the main aim of this experiment was to actually find the specific heat capacity of the metal. So the formula for specific heat capacity during in a practical is actually 1 over mass times gradient. So basically we just have 1 over mass, which you're obviously going to have of the metal already. So usually your teacher will tell you what is the mass of the substance that you have chosen, or you'll have to measure it yourself. So you basically get the mass, so 1 over mass times the gradient, and the gradient has to be from the graph. So you basically have to get your graph and you have to measure the gradient using the formula change in temperature over energy transferred. So after you've used the gradient, you basically have to do 1 over mass times the gradient. And again, as I said, where gradient of the graph is theta, temperature change over E. So that's basically how you're going to be finding the specific heat capacity of your metal, and you would have officially completed your experiment. So that's basically how you would do the specific heat capacity practical or experiment. I hope you guys enjoyed doing the practical, and I hope you guys have understood the purpose of doing this experiment. So what we have learned today is actually the basics of the specific heat capacity required practical. So we learned how to actually do it, the method, and also how to set up and record your results. Number 2, we actually learned how to record your results and actually complete the tables. And number 3, we also learned how to calculate the specific heat capacity from the graph that you actually create from your results table. So I really hope you guys have enjoyed this video. Definitely give it a thumbs up if you enjoyed, and subscribe down below for more free science and maths lessons from the school station. Bye guys!